friends, welcome to today's video on our graph series. I am Chinyelo, a software engineer at Microsoft Dublin, Ireland. Today we'll be solving a medium question from leetcode titled Find All Path from Source to Target. So by now, you should be comfortable solving graph algorithm questions. However, if you're still struggling, don't worry, I got you. It's always helpful to review the basics. I recommend watching my video on graph data structure and graph traversal for a detailed explanation of these fundamental concepts, because understanding these concepts is essential to mastering graph algorithms. So in today's video, as usual, I'll start by reading the question, pointing out exactly what the question requires from us. Then I will go ahead to explain my proposed solution using a pseudocode so you can implement it using any language of your choice and get the same result. I will also implement this solution in JavaScript and explain the time and space complexity of the solution. Alright, let's get started. The question says, given a directed acyclic graph of n nodes labeled from 0 to n-1. Find all possible paths from node 0 to node n-1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. That is, there is a directed edge from node I to node graph ij. So, for example 1, the graph is an array whose indices are the nodes and the values are the adjacent nodes. What this means is that in the graph array, node 0 points to node 1 and 2, node 1 points to node 3, and node 2 points to node 3. And finally, node 3 does not point to any node. It is important to note that the way the graph is represented in an array allows all nodes to be easily accessible, so we do not need to create an adjacency list as we did in the previous videos. For this particular example 1, n is 4, so our target is n-1, which is 3. And we are required to find all paths from 0 to 3, which are node 0 through node 1 to node 3, and node 0 through node 2 to node 3. The trick to solving this question is to traverse the graph from the source node, keeping record of all paths along the way that ends at the target node. We are going to use the breadth-first search approach. If you are new to graph traversal, I recommend watching my video on graph traversal. In that video, I explained breadth-first search, depth-first search, and recursion in detail. So, the first thing we will do is to determine our target, which is the length of the graph array minus 1, and assign it to a variable target. Next, we will create an array called results to store all the paths that go from the source node to the target node. It is worth noting that in previous videos, where we used the breadth-first search approach, we always enqueued nodes, but this time we will enqueue path. Now, let's define our queue and add the starting path as its only element. Note that we are using an array of arrays to represent path in the queue. Each path in itself is an array of nodes that we have traversed so far. So the starting path is an array that contains only the starting node. Now, we can start traversing the graph using this queue to explore all the possible paths. We will loop through the queue as long as it is not empty. And in each iteration of the loop, we will dequeue the first element from the queue as our current path and retrieve its last node. If this last node is equal to the target node, we just found a path from source to target, and so we push this current node into the result array. Otherwise, if the last node is not the same as the target node, we will retrieve the adjacent nodes of this last node from the graph array and loop through it. And at each iteration with the adjacent node, we will create a new path by concatenating the adjacent node to the current node and enqueuing this new path. Once the queue is empty, the loop completes and the result array is returned. Brilliant! Time to implement this in JavaScript. Feel free to implement this solution using any programming language of your choice. Alright, let's delete the pseudocode. Now, let's determine our target. Target is equal to length of graph array minus 1. Define the result array and the queue. Let result equal to an empty array. And let queue equal to an array with the current path as its only element. Now, let's loop through the queue using a while loop. Let's dequeue the current path from the queue and retrieve the last element in the current path array. Next, check if this last node is the same as the target node and push it into the result array if true. Else, retrieve the adjacent nodes of this last node and loop through it using a for loop. Create a new path using each adjacent node and enqueue this new path. At the end of the while loop, return the result array. Good. Let's test and submit our code. Great job. Now, let's look at the time and space complexity of our solution. The time complexity of the solution is O of 2 to the power of n times n, where n is the number of nodes in the graph. This is because the solution uses a breadth-first search approach to traverse the graph, and for each node, there are two options. Include that node in the current path or not include it. At worst case, the queue can contain 2 to the power of n elements, which means that the while loop that iterates through the queue has a time complexity of 2 to the power of n. Inside the while loop, there is a for loop that loops through all the adjacent nodes, and at worst case, there can be n adjacent nodes. Therefore, the time complexity of the for loop is O of n. So, overall time complexity of the solution is O of 2 to the power of n times n. Similarly, the space complexity of the solution is also O of 2 to the power of n times n. This is because in the worst case, both the queue and the result array can hold 2 to the power of n elements, and the adjacent nodes array can hold all n nodes. Therefore, the overall space complexity of the solution is O of 2 to the power of n times n. Thanks for watching till the end. If this video was helpful, please give it a thumbs up and hit the subscribe button to see more videos like this in the future. If you want me to solve any specific graph problem, leave a comment down below and I will add it to the list of my videos to create. Thanks again for sticking to the end. See you in my next video. Bye.